let me give you example here. Let's write example somewhere. Yeah, and let's take easy example, then it's fine. Okay, taking example of this hydrogen. Okay, plus hydrogen plus oxygen. What does it form? Hydrogen plus oxygen. Okay, forming water. So this is word equation, right? Now to convert this word equation into balanced chemical equation, now we have to follow these steps here. Number one step says that identify reactants and products as compound or element. Now look at that, hydrogen, oxygen, water. So here hydrogen is element, oxygen is element, and water is compound, right? So first let's identify. So here two reactants you can see, one product, hydrogen, oxygen reactants, and water product. So out of these three substances here, hydrogen and oxygen are elements and water is a compound. So first point we identified, right? Second one here, for elements, physical state need to be identified as most gaseous elements are diatomic and solids and liquids are monoatomic. So in this case, okay, hydrogen, oxygen, these two are elements. So point number two says, now forget about compound here, just look at the elements, hydrogen and oxygen. So here hydrogen and oxygen are elements. So if these substances are elements, then now what we have to think about, we have to think about their physical state. Okay, in normal condition, hydrogen and oxygen both are gases, right? Okay, in normal condition, both of them are gases, and okay, this point says that most of the gases are diatomic. Okay, most of the gaseous elements are diatomic. Diatomic means so their molecular formula will be like this. Two atoms will be there. Okay, two atoms will combine together to form the single molecule of that element. Like for example here, H2 for hydrogen, Cl2 for chlorine, O2 for oxygen, and 2 for nitrogen. Right? So that means here what I have to write. Okay, so hydrogen I have to write H2, right? H2, oxygen it must be O2. Okay, so now these two done, right? So you cannot write H only, you cannot write O only. Okay, symbol of hydrogen is H, fine. Symbol of oxygen is O, but okay, here in the equation what we write, we write H2 and O2. Only reason is these are diatomic gases, right? These are diatomic. Diatomic means the molecules having two atoms. Next point here. There are four compounds. The four compounds we may have to do crisscross, right? Crisscross method needs to be used to find out their molecular formula. Now water is here, so for this case it's kind of easy, right? I mean water H2O, I mean we easily know that. But instead of water, if there was some other compound, then we have to do what? Crisscross method. There might be sodium bicarbonate, there might be calcium sulfate. So in that all cases, we have to do crisscross. Remember how to do crisscross method? Just by exchanging the valency. By exchanging the valency, we can find out the molecular formula of some of the ionic compounds there. And by that, we can write the molecular formula of compound. So in this example I have taken easy one. Okay, so in this case, even if you don't do any crisscross, you can directly write H2O, right? H2O is the molecular formula of water. But instead of water, there was something, difficult to remember the molecular formula of. Then in that case, what we do? We do crisscross method. Anurag, do you know what is crisscross method? Anurag, do you remember? It was taught somewhere in class 8-9. Do you remember this crisscross method?
Yes, sir.
Okay, you can do crisscross method.
Yes, sir.
Okay, so that's very good then. So that's the third point there. Now let's go to the fourth point. Okay, fourth point here you can see skeletal equation must be written correctly. Skeletal equation must be written correctly before balancing the equation, right? Okay, so here I have written S2 plus O2 gives you H2O. So I mean, like, you must first write the formulas correctly. This is a skeletal equation here. I have written it correctly. So first you have to make sure this skeletal equation is correct. That means, I mean, if you write here H only, H plus O2, H2O, then the whole skeletal equation would be wrong. Okay, and then later on, if you balance it, so that balancing will not count anything if your skeletal equation is wrong. Number 5, balancing is done at last, right? We have to do the balancing at last. So I think I should remove this all drawing here. Let's remove. The balancing is done at last. So for balancing, what we do? For balancing, we always balance the number of atoms of different elements at both reactant and product sides. Okay, so balancing is always about atoms, right? We never balance the molecules. What we balance? We always balance the atoms. We have to look at the atoms in both the sides, reactant side and product side. And number 7 says number of atoms need to be counted well. So an example is given there. Okay, H2 and 2H. Okay, H2 and 2H. If you count the number of atoms, it's exactly same, right? 2 hydrogen in H2 also, 2H also. For balancing, H2 and 2H are same, but chemically, like, they have different meanings. I hope you understand that thing. Okay, better let's ask someone. Atif, tell me difference between S2 and 2H.
Sorry.
Difference between S2 and 2H.
Yes, 2 and 2H.
2H. Like you can see on the screen there. H2, H subscript 2, and then 2H.
There are two hydrogen. 2S means S2 means the valence of hydrogen is 2.
No. It's not about valence. Not about valence. Okay, so it looks like you forgot it completely. Okay, H2 actually means there are two atoms, right? Two atoms combining to form one molecule of hydrogen here. H2 means two atoms of hydrogen, they bond covalently to form one hydrogen molecule. But 2H means these are two separate unfused atoms. Okay, two free atoms of hydrogen. 2H means, so it's not a molecule. 2H is not a molecule, and H2 is a molecule. Okay, H2 means what? Molecule is there. Two atoms are bonded to form molecule. And when you write 2H, that means these hydrogen atoms are not bonded. They are free, unfused. So that difference was taught in class 8 and 9. But you forget it. But anyways, but for balancing, obviously, when you count the number of atoms, then it's same. You know, two atoms here, two atoms there. How many atoms of carbon and oxygen are present in CaHCO3 whole 2? So here also, like, now you need to understand how to count there. Counting is very important. Okay. So here you should understand there's only one calcium atom. There are two hydrogen atoms. There are two carbon atoms, and there are 6 oxygen atoms. Yeah, this thing. If you do not know how to count, then balancing is impossible for you, right? So first thing what you need to understand is you have to first be very perfect in counting. Okay, please look here. So in this formula, this calcium bicarbonate, again this formula, okay, how many atoms of different elements are there? Okay, let's count. Okay, how many atoms of calcium are there? Okay, you can clearly see only one calcium is there. Okay, Ca. Ca written. So if there's nothing, that we have to understand there is one, right? Okay, Ca1. And then if you look at this hydrogen here, okay, now this bracket plays very important role here. So this bracket and then 2 means, so this 2 is for all of them, HCO3. So here hydrogen, how many hydrogen must be there? Hydrogen also there will be 2. Okay, similarly look at the carbon there. Okay, carbon also there will be 2. So here invisible 1 is there, invisible 1 is there, and that 2 is there. So 1 into 2, 2. 1 into 2. And now look at the oxygen there. So 3 you can see there, 3 oxygen, 3 into 2. So that makes the 6. So how many oxygen there? There are 6 oxygen. Right? So that's how, I mean, counting should be done, right? Okay, 6 oxygen, 2 carbon, 2 hydrogen, 1 calcium. And for balancing, like the counting is very important thing. Once you understand the counting, then only you can learn how to balance them. Balancing is simply like making the number of atom of different elements equal in reactant side and product side. Okay, so let's move on the next slide there. Number 8 point there, please look at that. For balancing, any number may be used as to change the number of molecule of reactant or product, but molecular formula must not be changed under any circumstances. So for balancing, only thing we can do is we can change the number of molecules without changing the molecular formula. So let's take example here. Let's take example. Let's take an easy example. Okay. Yeah. Let's take example of hydrogen plus nitrogen. Okay. It forms ammonia, right? And H3. Okay. Now, so if you have to balance this equation, the first thing what you have to do, you have to count the number of different atoms. So in this is the reactant side, this is product side, right? In reactant side, you can see there are 2 hydrogen atoms and 2 nitrogen atoms. Now don't look at the molecule here. Obviously, it's like 1 molecule of hydrogen and 1 molecule of nitrogen there. Okay, but here, like for balancing, we look at the number of atoms here. 2 hydrogen here, 2 nitrogen there. But in the reactant, in the product side, if you look, you can see only 1 nitrogen there and 3 hydrogen, so obviously not balanced, right? Okay, 2 here, 1 here, 2 here, 3 here, so not balanced. That's why let's try to balance here. So 2 nitrogen here and only 1. So if I put it to this side, okay, let's put this side 2 here. So nitrogen will be balanced, but what I did, I changed the number of molecule. If you put number here, then it will be 2 molecules of ammonia. Okay, you cannot put 2 here. Okay, if you put 2 here, like N2S3, if you put 2 here, okay, for the sake of balancing, it may look like 2 nitrogen, right? But okay, by putting number here, you will completely change the molecular formula, and which is again not possible here. You cannot change the molecular formula. NH3 is ammonia, N2H3 is not ammonia. Okay, so that's why you cannot change that. So this N2S3, okay, this 2 cannot be put here. Okay, this thing is not possible. The only thing you can do is you can put any number here. Okay, 2, 3, 4, 5. We can put any number, and that would be like you are changing the number of molecules. You have 2 means 2 molecules of ammonia. It would 3 molecules of ammonia. So by putting 2, nitrogen will be balanced. Now look at the hydrogen here. So 2 hydrogen you can see here, but after putting this 2 here, so hydrogen would be how many? 2 into 3, 6. So there will be 6 hydrogen. So 6 hydrogen this side and 2 hydrogen this side, not balanced. So this hydrogen also should be balanced, and obviously you will not put 6 here. Okay. Okay, if you put 6 here, then like this again will be completely wrong. H6 is not the formula of hydrogen. Okay. So what do you have to do? You have to put 3 this side. Look at that. So what I'm just doing is I'm just writing the numbers to change the molecule number, and without changing the molecular formula. I have not changed any molecular formula here. S2 is still S2, N2 is still N2, and NH3 is still NH3. But what I did here, I balanced the chemical equation. If you count the number of atoms, so that would be same. 6 hydrogen here, 6 hydrogen this side, 2 nitrogen, 2 nitrogen, right? This is one example. And to be perfect, like you always have to practice it. And number 9 says hit and trial method is used for balancing chemical equations, right? So example, like I have given one example here. You can finish the example here. Okay, is there any